Okay, so we are again going to practice for another question in which we find the work done with the help of graph. Okay, in which we find work done with the help of graph. And the question is quite simple. Let me draw the graph. Okay, this is y axis. This is a force. Okay, at y axis, and let me draw the x axis. Okay, this is x axis, and this is x axis, this is y axis. Okay, along with forces. Now okay, so this is 4 Newton, this is 2 meter, this is 4, this is 5, this is 3. Okay, this is 2 minus 2. Okay, and this is 6. So find work done. Find, we write out the question here. Find work done from x is equal to 0 to x is equal to 4, sorry, x is equal to 2, then from 3 to 4. Okay, then from 0 to 6. Okay, we have to find work done in all this. Okay, so guys, first, what is the work done? Work done is basically dw is equal to f dot ds. Okay, so here displacement, only displacement taking place only along x-axis. Displacement taking place only along x-axis. So we know that ds is equal to dxi plus dyj and plus dzk. Okay, so displacement taking place only along x-axis. So these two guys will be 0. This will be 0 and this will be 0. Okay, these two guys will be 0. So what can I write? ds is equal to dxi. Okay, so and no, the force only acting along x-axis. Okay, the force only acting along x-axis. So what can I write? F is equal to vector F is equal to fxi. Yeah, you should know how to write the force in vector manner. Okay, if you got a graph like this. Okay, fxi plus 0j plus 0k, because there is no force in along j and k axis. Okay, so what is the dw? Dw is equal to basically dot product of these two vector. So fxi plus 0j plus 0k dot dxi. Okay, so what can I write? Fx dx, because all the quantity become 0. Okay, so and this will be the dw. So what is the w is basically integration of dw. Okay, and it become fx dx. So from in first question, x is varying from x is equal to 0 to x is equal to 4. This means x vary from this. Look at my pencil. Okay, x varies from this to this. Okay, now here, look here, the force is not constant. Here x is equal to 0, force is 0. X is equal to, at this point, force is this. Okay, and this point force is this. Force is not constant. Okay, and so the force is varying according to this equation. Okay, guys, you know we know the meaning of integration. Integration is basically, if I say that displacement taking place from x is equal to 0 to x is equal to 2, you know, this means that no work done will be basically area under this curve, area under this whole area. Okay, this whole area will be basically work done, this whole area. Okay, so you know, so we have to find this area, and you know and you know, if we are going to write down the equation and finding the area, that it will take slightly more time. Okay, you should do it by yourself. What I will do, I will just find this area. Okay, so you know and okay, before finding area we have to think about as work done will positive or negative. Okay, work done is positive. Now guys, here, what is the direction of force? The force acting along positive axis direction. Okay, direction of force, force direction, force direction. Okay, it is positive x-axis, positive x-axis. Okay, this means this is the direction of force. What is the direction of displacement? Displacement also taking place from x is equal to 0 to x is equal to 4. This means direction of displacement is positive. Okay, displacement is also this. So this is the force direction, this is the displacement, and both are positive. Okay, both are in same direction. So you know work done will be positive. So work displace, so work done will be positive. Okay, okay, you have to just do slightly some practice, then you are able to determine, you see the question and know that this work done will going to be positive. Okay, so but you know, to learn this concept you have to think in this manner. Okay, in copy nobody write that ts is equal to dxi dyj dzk, you know, but for practice, to understand it, to grab the concept, you have to write in this manner. Okay, so you know dw is so w work done will be positive. So finally we have to find somehow this area. You know, look, this is the triangle, and so area of this triangle, you know, that base into height. So area will be 1 by 2 into 2 into 4. So this area will be okay, and the work done, and this area will be work done is equal to work done, and it is positive. Okay, so let me write down plus 4. Okay, so what is the work done from 0 to 2 is plus 4 joule. Work done is equal to plus 4 joule. Okay, look at this, work done is equal to plus 4 joule. Okay, uh, now now we are going to find out work done from x is equal to 0. Okay, where is x is equal to 3 to x is equal to 4. So now we have to find work done between this region. Okay, work done, this means we have to find this area. Again we have to think that work done will be positive or negative, and by same method we know that force acting, you know, because here f is positive, so that what is direction of force is positive x-axis, positive x-axis, because f is positive x-axis. And you know displacement taking place from x is equal to 3 to 4, you know, this is the displacement. So displacement is also positive. Okay, displacement is positive. So you know, so work will be positive, so work done will be positive, because angle between them is, angle between displacement vector and force vector is 0. So work done will be positive. Okay, so now we have to find just this area, we have to find this area. Okay, if you look at this, this is the geometry of what, this is geometry of rectangle, and this length will be 1 and this length will be 4. It is given as this length is 4. So what is the work done? Work done will be plus 4 into 1, that will be 4 joule. Okay, now we have to find work done from x is equal to 0 to x is equal to 6, when displacement taking place from 0 to 6. Okay, okay, so we have to find this total area. Okay, we have to find this total area. Where is this? We have to find this total area, this and plus this area. Okay, okay, so you know, we know this area is plus 4, and then this area we know, we have to just calculate this area. So this length will be 2, this length from here, this is 2, this is 4, so this length will be 2. Okay, this length will be 2, and this length will be 4, this length. Okay, look at my pencil, this length will be 4. So what will be this area? This rectangular area will be 2 into 4. Okay, and in both case work done will be positive. Both case work done will be positive. Okay, so what is this total positive area? What is this total positive area? This total positive area is 8 plus 4, that will be 12 joule. Now we, between this, what is the area? This area, here the length is 1, this length is 1, but height is 0. So this area between this, between 4 to 5, when displacement taking place 4 to 5, there is no force acting on it. Okay, so work done will be 0. Displacement taking place, but displacement taking place without force. Okay, so work done between 4 to 5 will be 0. So so plus 0, and then after that, force become negative. This means, force acting along negative x-axis along this direction. This is direction of force, and displacement taking place along this. So what is the angle between them? Angle between them 180. So cos 180 will be negative. Okay, cos 180. Think about why I write cos 180. Okay, is negative. Think about it. Why I think about cos 180. Cos 180 will be negative. So work done will be negative. So work done negative. Okay, so work done will be negative. Okay, so this is the direction of work done. Okay, work done will be negative. So we have to just find this area, and we know that work done, we had concluded that work done will be negative. So what will be this area? This length, which is 1, area will be 1 by 2 into, and this height is 2 into 1, that will be 1, and work done is negative, so minus 1. Okay, so work done will be minus 1. So minus 1. So what is the total work done? Look at this. I am just writing here total work done. Total work done will be 12 plus 0 minus 1, that will be 11 joule. Okay, so this will be the total work done. You should do it by yourself. Thank you.